Okay, welcome back, everybody. So, today I just want to review for the quiz tomorrow. Okay, quiz is tomorrow, section 6.4 to 6.6 quiz tomorrow. So here's what we're going to do. We're going to go over problems 32 to 54, even on page 475. And then with the remaining time, I've just got practice problems to do. Okay, and that's all we're going to do. We're just going to go over some problems with any remaining time. You can just study on your own, but who knows if we're going to have remaining time. So let's take a look here. There's 32, 34, 36. Go ahead and check your answers and ask questions where you need to. Again?
Yeah, we were all like screaming, and he's like, "Welcome back, everybody!" Like, right
I hope you all can hear me. Crazy in here. Okay, so for I did not unfreeze the board there. Okay, there we go. So for number 32, x minus 1 is a factor of p of x. Why do we know that? Because of the 0 here. Don't forget the 0, looks like the x to the second, whatever this power. That was not included. So you make sure that you put in a 0. Right?
It might have been the first.
Yeah, it's the third.
I might have liked you.
Constant, first, second, third, yeah. Number 34, you had to factor that one by grouping. I would have pulled out, they eventually did. Pulled out the negative 16 as the GCF. So x squared minus 16, and then x squared just x minus 1. And then don't forget to factor that into x minus 4, x plus 4. Now, did you have to solve there? Did you have to get x equals? No, because the problem just said factor. It didn't say solve. It didn't say find the roots. It just said factor. And I do take points off for that. Like if you write x equals 1, x equals plus or minus 4, I will take points off for that because that is not technically factored. I need to see it in the full factored form. That also includes the ones where I say solve by factoring. If you just factor, the direction was to solve. If you just factor and you don't get your x equals, then I do take points off for that too. Number 36, you factor out the 3 and you're left with an x to the third plus 27. Remember the rule is if you've got a sum or difference of cubes, it's a to the third and then b to the third, whatever they are, as long as there's two terms that are both perfect cubes. Remember, what's a perfect cube? Well, you can test it out and calculate for the number. For a variable, the power is divisible by 3. If you've got two perfect cubes, and it doesn't matter the sign in the middle, it could be a plus or a minus. It's going to factor into something that looks like this. You have a and b, and then we have squared, product, squared. And now, how do we tell the signs in the middle? Well, remember, that's the SOAP rule. Same, opposite, always positive. Same, opposite, always positive. So, for example, if this was a plus sign, this would be a plus, minus, always positive. Same, opposite, always positive. Same sign, opposite sign, always positive. If this were a minus sign, whoa, don't do that. If this were a minus sign, up there, then it would be same, opposite, always positive. So, for this problem, we got x to the third plus 27. Those are both perfect cubes because that's x and 3 as the cube roots. So we've got x and 3 squared. X squared product is 3x. Squared is 9. Same, plus, opposite, minus, always positive. Questions about that? Okay, good. Here is numbers 38, 40, and almost 42. 42?
Yeah.
Yeah. All right, let's take a look at 42 real quick. Did the directions say factor? Or did they just, factor to solve, or did it just say solve?
42.
Just said find the roots?
Find the real.
Yeah, or find all real roots or something like that? Okay. Because, I always say you should exhaust your methods of factoring first, right? Let's just do this one brand new. You should exhaust your methods of factoring first. Well, that means that I would try to factor this one by grouping, and this one does factor by grouping. You pull out the x squared, you're left with an x plus 1. You pull out the -2, you're left with an x plus 1. Right? Two negatives cancel out, make a positive. So that means my two factors are x squared minus 2 and an x plus 1. Notice that x squared minus 2 does not factor down. That is not a difference of squares. Spoiler alert, 2 is not a perfect square. I know, right? X squared minus 2 is equal to 0. X plus 1 is equal to 0. And then we could say, okay, x squared is equal to positive 2, so x is equal to plus or minus radical 2. And then x is equal to negative 1. Does that make sense? Now, the other possibility of doing this is that, well, if I didn't even want to check factoring, if the problem didn't say solve by factoring, and I guess I didn't need to show that work, if it says solve by factoring, I'm restricted. I've got to use factoring. I can't use my calculator. I would go in and say this. Well, this is x to the third plus x squared minus 2x minus 2. And I go to graph that. Look at what I see. Do I see a double root at -1? No, that can't be true. Oh, it actually crosses, we just don't see it. So it looks like we've got a factor at -1, right? And this one might be deceiving because of that. Oh, my voice did that. But this one might be deceiving because of that. Because it looks like there should be a double root at -1, but there isn't really. Like if I plug in -1, and I see 1, 1, -2, and -2. Okay, 1, -1, 0, 0, -2, positive 2, 0. I would have x equals -1, that's that one. And then x squared minus 2 is equal to 0. And then we get our x is equal to plus or minus radical 2. So is there actually a double root at -1? No, even though it looks like there is. And the reason being is that our calculators, and maybe you could see it better on your guys' fancy dancy calculators, but on mine, I don't have enough pixels to show. But if I zoom in, I do see that it does cross over. So it's a little deceiving. The reason being is that the square root of 2 is so close to 1 that it almost looks like it's the same point when we don't have enough pixels to show it. All right, I digress. There's 44. Well, almost 44. There's 46 at least. Please don't try to say x plus 1/2. Please don't do that. Because your answer would have been x to the third minus 1/2 x minus 13 halves minus 3. Okay, so we did 42. Number 44, it looks like the width is x, the length is 2x, and the height is x plus 4. And to find those, and then to find the volume of the box, you set those all equal to 48. The product all equal to 48. X times 2x is 2x squared, times x plus 4 is 2x to the third. I'll say x squared. And then you subtract over the 48 to get that 2x cubed plus 8x squared minus 48. You factor out the 2. And then how do we find the 0 of this? Calculator. That doesn't factor because it leaves with an x to the third. It's not a trinomial, a factorable trinomial. It's not a quadratic trinomial. So, and since it's a cubic trinomial, that doesn't factor correctly. So you'd have to go into your calculator. You're stuck. You go in, you see x equals 2, and then the other piece does not factor. Now, ladies and gentlemen, if it doesn't factor, is it going to be rational or real? No. I mean, excuse me, is it going to be whole? I guess I should have said that. Is it going to be whole number? No. I said that right the first time. Is it going to be rational? No. I guess I should have just said it. Is it going to be rational? It's going to be either irrational or non-real, right? So therefore, I could have stopped there. Once I've seen that it is not factorable, you could be like, no, okay, the other two roots are not going to be rational, so I can stop. Turns out that they're non-real. So the only possible solution is an x equals 2, which means the width is 2, the length is double that, 4, the height is that plus 4, which is 6. And then we have number 48 there. See, that one is done a little weird. I would have done the prep work a little different. If I had said x is equal to plus or minus I, you'd say x is equal to plus or minus the square root of negative 1. So x squared is equal to negative 1. So x squared plus 1 is equal to 0. And that's where we get the x squared plus 1. And then you just multiply those two things, boil them out. Yeah.
I don't think I have to do the ones that are the cube.
Which one?
Like the one that was like this side of this side of this. The cube ones.
Oh, the volume of the box. The volume of the, yes, we will go through another volume of the box problem today. Those are hard. But I will tell you that this is the process. Figure out the dimensions in relation to x, right? What is the width? Define for yourself. Make a list for yourself. What is length? What is width? What is height? Multiply all of those things together. Get your polynomial. Subtract over the volume and get yourself your full polynomial that you need to factor down. At that point, go to your calculator and figure out where it crosses the x-axis, and that's going to be your solution. Okay. We'll do another one. Don't worry. Anybody still need anything on this page? You're going to flip over to the next page to see the rest. Okay. Here's 50. Again, I would do the prep to 50 a little different. Let's take a look at how 50 is going to work. So this one is, this is using the method that I showed you guys yesterday. I would not do that method. Let's take a look here. What can I hide? I can hide all of this. Yeah. Okay. So this is going to give me x is equal to 1 plus or minus radical 3. Which means I got to isolate the square root. I've got to subtract the 1 over to the other side. So x minus 1 is equal to plus or minus radical 3. I square x minus 1. X minus 1 squared is equal to 3. I actually square x minus 1 now. X squared minus 2x plus 1 is equal to 3. And then I subtract over x squared minus 2x minus 2. And that's where you see that. And then with the plus or minus 2i, x is equal to plus or minus 2i. Well, remember, I is the square root of negative 1. So 2 square root of negative 1. I put that 2 back underneath the radical. X is equal to plus or minus radical negative 4. Then I square. X squared is equal to negative 4. And then x squared plus 4 is equal to 0. And at that point, the work is the same. Okay, let me scroll down a little bit. There's the rest of 52. Number 52, that's that weird one where I would have said, replace a in for x squared. You would have gotten a squared minus a plus 2, which is a minus 2a plus 1, which will factor into x squared minus 2, x squared plus 1. And then neither of those are difference of squares. You can't factor either either of those down anymore, so you gotta just solve those. X is equal to plus or minus radical 2, x is equal to plus or minus I. Okay, let me scroll down a little bit more. You can almost see 54, almost. Anybody still need 52? Yeah, okay, I'll leave that there for a second. Just to reiterate where we're headed, we've got our quiz tomorrow, and then next week we're going to do sections 6-7, 6-8, 6-9 on Monday, Tuesday, Wednesday. We will start reviewing for Chapter 6 test on Thursday. We will have a group test next Friday.
Yay.
Is that our first one this year?
Yeah.
We canceled the other one.
We canceled the other one because I got sick, remember?
Ridiculous.
Which is all the more reason to have a group test.
Exactly.
I love group tests.
You said that.
Group tests are so much fun.
Can you explain them to us?
Hey, can you be in our group?
Well, so here's what's going to
You got
happen.
way too excited about well.
Well, because kind of. So here's what's going to happen. I'm gonna gather you guys in groups of 3 or 4. Oh yeah, that's right. I did talk about this. If you guys want to do this. I'm gonna put you guys into groups of 3 or 4, and I give you one test, and you guys have to agree upon answers for that test. And it's not summative. Okay, it's a big formative grade. Okay. I don't like giving it in summative because I force you into agreeing on your answers. And if you don't agree with the person next to you, if you think that they're wrong, I don't want that counting against you on your summative grade. So like, and I don't want anybody to come back to me like, oh, my group's so good, so I got a bad grade, you know? Because I hate that. I always hated that part as like a student, like being in my like English projects, and it was like, oh, well, I did like 80% of the work, and this guy that slacked off, and I only got 20%. Same grade I did, whatever. Flashback type stuff. So it's still a grade, but it's just a formative grade, not a summative grade. That's the way we get around that. Now, I give you one test, you agree upon everything, and you get 3, and it is more difficult than the individual test. Yeah, much more difficult. And it's planned that way. I force you into working together. They're almost too difficult to do them by yourself in terms of time and in terms of actual difficulty. I love those days because it forces you guys to work together. It forces you guys to work together. So they're real, and it forces you guys to like reason through the problem together. It's really fun.
Do you have to do the problem together, or could you just split it up?
Oh, you can split it up. Like, and that's why I encourage that. Like, okay, you take problem number 7, I'll take problem number 3. We'll work on it and see what. Maybe we'll pass it around and see what we can do here. You know, I'm not actually sure how many questions are on it or anything, but it does take like a full period. But the cool thing about it is you get 3 cheat cards. So you get 3 cheat cards. One of them is I can answer a yes or no question. Okay, I can answer a yes or no question. So yes, you can ask me, did we get this question right? And I can say yes, or I can say no, but I can't elaborate on that. So if I say no, whoops, you know, and that's it.
Can we be like, can you tell me exactly what I did wrong on this if it's wrong?
It's just a yes or no question.
Right.
The second card is I can help you through a problem or part of a problem. If you're stuck on a certain place, I can help you through it. I can give you hints. And then the third card is you can work with another group for 2 minutes. And you can say like, okay, I've got problem number 2. You guys got problem number 4, and you can be like, okay, yeah, okay. And then you both have to use that card at the same time. If you don't use cards, you get bonus points.
I would wait till the very end.
So if if you're like, oh, we get a bonus point if we don't use this yes or no card, let's just hold on to it, and then you get a bonus point. It's all relative to the actual amount of the final test. Like if it's a percentage on it. It all depends on how many points there are that we can see a little. Yeah.
So is this like our test for the chapter, or we have a individual?
So that's a great question. So next Friday, you will take your group test. On Monday, we will go over that group test and review a little bit more. And then that following Tuesday, you will take your individual test.
Well, I might have to go.
And that's the summative quiz.
Next Friday?
What I like about the group test, is that it thoroughly prepares you for your individual test. It thoroughly prepares you for your individual test because the group test was more difficult. So, and if you can logically reason through the problems on the group test, you're going to be fine for the individual test. So, I love those days. They're a lot of fun. You get to see you guys all work together. Brain power in here.
Would there not be like enough time for, if we wanted to each do, okay,
Yeah, if you said, okay, let's all do all of these problems,
Yeah.
you would run out of time.
okay.
Oh, man.
Because that would be the best way, because then you'd be like, what did we get?
You can cross-check
Three of us got
answers.
this one.
Yeah, there's not enough time for that. So. All right, here's 54. Again, this one you could have done it in any way, but it looks like this one factored. You see that it's got x equals -3 and then x equals plus or minus radical 5. Again, if it didn't say to just factor, you could have put this in your calculator and seen that it crossed at -3 and then synthetically divided out the -3. You would have got an x squared minus 5 in the end after synthetically divided, so x equals plus or minus 5, or plus or minus radical 5. All right, any questions on any parts of the homework? Page 475, yes?
So when it's like an answer like this, it's okay if we just put plus or minus 5, right?
Yeah, that's totally fine. Yeah. And I am very explicit on when I want multiplicities. Okay? So make sure that if I ask for multiplicities, there will be an extra blank there. State the multiplicity. State the multiplicity. All right. All right, any other questions on the homework? Okay, let's just do some extra problems here. You want to start up? Let's start off by doing the volume of the box. I'm going to give you guys some time to work on this. I want you to try to figure it out on your own. And see how you do. I don't want you guys to get too far along with the incorrect work. So I'm just going to kind of talk through the first part to get the polynomial. The width, everything is dependent upon the width, right? the compartment must be 2 meters longer than its width, and the depth must be 1 meter less than its width. So both length and depth is dependent on the width. So width is x. That means length is x plus 2, 2 meters longer than its width. And that depth is x minus 1, 1 less than its width. So those are our 3 dimensions. And I multiply those together. So I get x cubed plus x squared minus 2x. And you set that equal to 8. And then you subtract that 8 over to the left side. Go from there, if you have not already done so. Okay, so there's the graph of that. Where does it look like it crosses? 2? I hope it actually does cross at 2. When we see here, it does. We synthetically divide with a 2, we get an x squared plus 3x plus 4. And when I go to factor down that x squared plus 3x plus 4, it doesn't factor. You at that point, you could have stopped. But just for fun, we see that it's non-real. That means my only solutions are 2, 4, and 1. So x equals 2. That was my only solution, x equals 2. So therefore, when you plug it back in, x equals 2. Width is 2. Length is 4, double that. With depth is 1 less than 2, which is 1. Always test it back out again in the end. Did my volume actually equal out to be 8? Yeah. 2 times 4 times 1 is 8. So I got a box that meets those requirements, and the volume is 8. All right, questions on that one? Again, the process is figure out your dimensions in terms of x. Multiply all of those together. Set it equal to your volume and find your polynomial by subtracting it back over. Go to your graphing calculator to find the root. Make sure that it's the only root by just checking to make sure it's not factorable. Plug it back in to find the actual dimension. Do you want to do another sum and difference of cubes problem? Let's do that. Let's take a look at this one here. 2x to the 7th plus 16x to the 4th. Okay, so for this one, obviously we would go through our flow chart, our factoring flow chart. Is there a GCF? Yeah. There's a GCF of 2x to the 4th. So I remove that, it's x to the 3rd plus 8. Look at that. So, we say 2x to the 4th. And then we got a binomial and a trinomial. Same, opposite, always positive. And then we cube root and cube root, x and 2. Squared, product, squared. And there's my answer. Notice that it didn't say solve by factoring. I don't have to get x equals. I just factor down. And that's it. That's where I leave it.
Yeah, how do you
I take the cube root of each this and this. So the cube root of x to the third is just x, and the cube root of 8 is 2. That's where I get the x to the 2.
Oh, what the heck is this cube root?
A cube root? A cube root is figuring out what number multiplies by itself
How do you even draw that?
3 times.
How do you even like draw? What's the symbol?
And yes, you can do that on your calculator. If you go back out to your home screen here and you hit math, it's right here. Choice 4 in my calculator. The cube root of 8 is 2. So if you're looking for, I don't know, the cube root of 343, 18 point whatever. The cube root of, oh no, that's square root. I was going to say that's not. The cube root of, I thought this came out nice. Yeah, it's 7. I was going to say, I thought that was 7. All right, questions about that one?
Algebra is overly confusing and frustrating.
What? Yeah, at times, yes. That is not wrong. All right, here we go. You know what? I want to do one where I have to state the multiplicity. Let's do this one instead. Now, all of these problems are posted on Canvas. The key to these problems is not posted on Canvas, but all of these problems are. So if you're doing a problem and you're like, I don't think that's right. I mean, there's times where you're pretty confident you know that you're doing it correctly. If there are times when you're, you're doing those extra problems and you're like, I'm unsure, send me a message say, like, hey, is the answer to number 1 on the review this? And then I can say yes or no. I can answer yes or no.
3 a.m. Hey, I'm
I can answer yes or no.
Answer it back in like 2 minutes.
Yeah, Philly.
How can I get my assignment greater than 1?
For me?
Yeah.
Well, I have to do my schoolwork when my kids do it.
I always do that because you always record your videos really, really late. He waited till it's been specific.
Yeah. And I put Sadie down at 8.
I wish you wouldn't do that because I would rather your kids run around in the background. Because that would be so funny. Your cat's already funny, but your cat's
Yeah, really. My noisy cat. Okay, so 2x to the 4th minus 4x cubed minus 64x squared plus 192x. Well, the first thing that I would like to do is pull out the GCF. So let's do so. These are all even, so I know I can pull out a 2. And they all include an x, so let's pull that out. Leaving an x to the 3rd minus 2x squared minus 32x plus 81? 192 divided by 2? 96. 81. Oh, I was thinking, never mind. Yo, yikes. I was thinking 162. 96. All right, that's still all equal to 0. Now, I would try to factor by grouping. Doesn't work. So what I'm going to do is I'm going to go in here, and I'm going to factor, or I'm going to put that into my calculator. So I go in here and I say, okay, x to the 3rd minus 2x squared minus 32x plus 96. And let's see where that hits. Straight through. Ooh, and a bounce.
Whoa.
See, what does that tell me? That tells me that this is a multiplicity of 1. Whatever this one is a multiplicity of 1. And whatever this one is, it's an even multiplicity. I don't know what it is just quite yet, but it's an even multiplicity. At least 2, right? All right, so let's use this one on the far left side. Looks like it's -1, -2, -3, -4, -5. -6 looks like. Let's test it out. Let's see if that is actually a -6. 1, -2, -32, and 96. All right, but that's a 1, a -6, a -8, 48, and that's a positive 16, which is a -96. It is indeed at -6. All right, so we bring down our 2x. Don't forget about that GCF. This turns into an x plus 6. That's my corresponding factor that has that root. And then we say, okay, x squared minus 8x plus 16 equals 0. And that factors. Factors of 16 that add to get to negative 8, negative 4, negative 4. So I've got 2x, x plus 6, x minus 4, x minus 4. So my solutions are, remember, if you factored out a GCF that includes an x, you set it equal to 0, you get x equals 0. Now, is there any multiplicity other than 1 on 0? No, because the power, like if this was an x squared, the multiplicity would be 2. If it was an x cubed, it would be multiplicity of 3. X to the fourth, multiplicity of 4. But it's just an x, so it's multiplicity of 1. We got x equals negative 6 from this one here. And then we got x equals 4 with those two, right? So x equals 0 and negative 6 both have a multiplicity of 1, because it's only there one time. But 4 has a multiplicity of 2, because it's there twice.
I'm gonna fail this.
No, you're not. Well, the good thing is you got a whole day to figure it out.
Oh, actually, I probably don't, because my parents are gonna make me do it online for 3 hours.
Yes.
So if there's just like a multiplicity of 1, do we have to like state multiplicity of 1, or we just like?
Yeah, technically you do have to state the multiplicity of 1.
Okay, but I was just wondering.
That's a valid question.
I know, but I thought the same question, but they.
Yeah, but you gotta take the multiplicity of all the roots.
Oh, John.
All right, any other questions or anything? No? Okay, I'll leave it go there, give you guys a little 5 minutes to relax on your own here. I'm gonna stop the video.
Peace out, Jerry.